Hello everyone, welcome back to my channel Study Motivators. This is model number 4 and model name is Design for Shear. Okay, today I am going to solve one more problem related to the problems on principal stresses. Okay, this is problem number 1. A concrete beam having rectangular section 200 mm wide and 400 mm deep. Okay, means solution B equal to 200 mm and D equal to 400 mm is prestressed by parabolic cable having an eccentricity is 120 mm at the center of the span reduced to 0 at the supports. Okay, eccentricity means E, small e. Okay, small e equal to 120 mm. The span of the beam is 10 meter, means L equal to 10 meter. The beam supports a live load of 2.5 kilonewton per meter. Live load means capital LL equal to 2.5 kilonewton per meter. Find the effective force in the cable to balance the dead load and live load on the beam. Means find the effective force means P equal to question mark, and also find the principal stresses at the support section, and concrete density is 24 kilonewton per meter cube. Okay, density of the concrete means density equal to 24 kilonewton per meter cube. Okay, this is given data. Now draw the figure. This is beam section having a width is B equal to 200 mm and overall depth D equal to 400 mm. Okay, this is the cross section of the beam. Now draw the longitudinal section of the beam. Okay, okay, this beam carrying a UDL load of means live load equal to 2.5 kilonewton per meter and the span length L equal to 10 meter. Okay, and is prestressed by a parabolic cable having an eccentricity is 120 mm at the center of the span to reduce to support section. Okay, means eccentricity is located at the midpoint of the beam to at the bottom position. Okay, so eccentricity is located here. So E equal to 120 mm. Okay, this is the longitudinal section. Okay, this is the figure. Now step number 1, load calculation. This is first step. So self weight of beam equal to, formula is B into D into density. Okay, so B is also given in question 200 mm and D is 400 mm and density of the concrete is 24 kilonewton per meter cube. Okay, this B and D is converted into the meter. Okay, so 0.2 into 0.4 into density of the concrete is 24. Okay, and self weight of the load is 1.92 kilonewton per meter. Okay, then live load is given in question 2.5 kilonewton per meter, and add both the load. So total load is 4.42 kilonewton per meter. Okay, this is first step. Then step number 2, calculation of effective force. Okay, so formula is P equal to V by sin theta. Okay, here we don't know V and sin theta. Okay, first find the V and sin theta. Okay, so V formula is WL by 2. Okay, for simply supported beam. Okay, so WW is 4.42 into L is length is given question 10 meter. Okay, 10 divided by 2. Okay, now we got V as a 22.1 kilonewton. Y kilonewton means 4.42 in terms of kilonewton per meter into, and length is in terms of meter. Okay, cancel both meter and meter and we got kilonewton. Okay, now find the sin theta. Okay, so sin theta equal to, formula is 4E by L. Okay, so 4 into E. E means eccentricity. Eccentricity is given question 120 mm. So E 120 mm is converted into the meter because L is in terms of meter. So 120 mm means 0.12 meter divided by L is 10 meter. Okay, we got sin theta as a 0.048. Okay, now find the force P. So P equal to V by sin theta equal to V is 22.1 divided by sin theta is 0.048. Okay, we got P as 460.41 kilonewton. Okay, this is step number 2. Then step number 3. Step 3, calculation of principal stress at the support. Okay, this is that step. So formula is P by A. Okay, P is 460.41 kilonewton. Okay, 460.41 kilonewton divided by area. Area means B into D. Okay, B is 200 mm and D is 400 mm. So area is B into D, 200 into 400 mm. Okay, this force is converted into the Newton because stress unit is Newton per mm square. So into 10 raised to 3. So 1 kilonewton equal to 10 raised to 3 Newton. Okay, so now we got answer as a 5.75 Newton per mm square, because force is in terms of Newton and area is mm into mm. Okay, so Newton and mm into mm square. Okay, this is the final answer.